Welcome back. Today's lesson we'll look at exponential notation, or sometimes referred to as scientific notation. So looking at putting numbers that are in regular form into scientific notation, as well as taking numbers that are in scientific notation and putting them back into regular notation. So if you have this sheet, we'll just make a little note right over here in terms of the process of how to do it. So if we're going from regular to scientific notation, there's a couple of steps that we have to do. So the first step is place the decimal after the first non-zero digit from the left. Okay, so going from left to right, we can put this decimal after the first non-zero digit. And then the factor of 10 exponent is equal to the number of movements required to make the original number. So it's kind of a long-winded explanation, but that's how it works. So you look at, where do I need to move the decimal to get the original number? And of course, it really shows us as doing a few examples. So over here, if we look at the number 100, if we place the decimal after the first non-zero digit, so it would be 1, and I can write these zeros here. Okay, so in all of these, or if I go here, it's going to be 1.0, and I'll just write a few zeros down just for now, because that gets into significant digits, which we'll look at later. So here, now where would I move this decimal to get the original number of 100? I'd have to move it 2 to the right. So whenever I move to the right, that's considered a positive movement. Whenever I move to the left, that's considered a negative movement. So moving it 2 places to the right, it's going to be a 2. Okay? With this next one, where would I move this decimal to get the original number of 100 million? So it would have to be 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. And if we look at numbers that are less than 1, so placing the decimal after the first non-zero digit, that would make it 7.3. And let's see, where do I move it to get the original number? 1, 2. 2 to the left, so it's going to be a negative 2. If I look at this one, place the decimal after the first non-zero digit, so 4.5. And to get the original number that you see here, it would have to be 1 movement past the 4 plus 6 zeros, so that's going to be negative 7. Okay, so that's how questions 1 to 20 work on this page. If we look at the bottom part, doing vice versa, going from scientific notation to regular, it's very easy. All you have to do is simply move the decimal the indicated number of places. So you simply kind of do what it tells you to do. So over here, in this 1 times 10 to the 3, we of course know that the decimal is after the 1. It's not written, but we know it's there. And moving it 3 places to the right. 1, 2, 3 would involve 1, 2, 3. So 1,000. If I look at this one, 5.6 times 10 to the 5. So my decimal, which was here in between the 5 and the 6, 5 places to the right. 1, 2, 3, 4, 5. So 560,000. And if I look at vice versa here, we're going in the opposite direction. 4.3 times 10 to the negative 3. So of course negative implies going to the left. So moving it to the left 3 places. 1, 2, 3. It would look like that. And usually it's common practice to put a 0 there. So that's how you do 1 to 20 on the bottom when we're going from scientific notation back to regular notation. All right, so you should be able to complete that whole sheet. We'll see you again.